Good morning, good afternoon, and good evening, everyone. Dear authors and distinguished guests, welcome to Technical Session 8B. I'm Sanskriti and I'll be moderating this session. On behalf of the Global Knowledge Research Foundation and GR Scholastic, it is my pleasure to welcome you to the 11th International Conference on Information and Communication Technology for Intelligent Systems, that is ICTIS 2026, being hosted in Bangkok, Thailand. This 11th edition is being conducted in a hybrid mode. The virtual sessions are being conducted via Zoom from 9th to 11th April 2026. I hope you find today's session insightful, engaging, and intellectually enriching. In this session, we have 10 presentations. Each presenter will have 10 minutes for the presentation, followed by 2 minutes for Q&A. A gentle reminder will be given at the 9 minutes mark. All participants are requested to remain connected until the closing remarks. For any queries or updates, please use the chat box. Now, before we begin, I would like to introduce the session chairs for this session. Our first session chair is Dr. Nhan Thi Ho, who is the acting dean of the Faculty of Information Systems at the University of Information Technology in Vietnam National University, Vietnam. With approximately 26 years of academic experience, her expertise includes artificial intelligence, financial technology, and cloud computing, focusing on advancing digital innovation and information systems in higher education. Ma'am, would you please like to give any welcoming remarks?
Thank you, Miss. Good afternoon, professors and researchers. My name is Nhan Thị Cao. I'm from the University of Information Technology, which belongs to Vietnam National University, Vietnam. It's great honor to be here today with you as a session chair of the ICTIS 2026 Thailand. We are pleased to welcome all the professors and researchers. We believe that all of your research presented here today will bring significant value to the research community. And we truly appreciate your time and wish you all the best. Thank you.
Thank you for encouraging words, ma'am. This session is co-chaired by Dr. Aarti Prashant Suryavanshi, who is an assistant professor at HSB PVT's GOR Faculty of Engineering in Maharashtra, India. Her research areas include data analytics, software engineering, and emerging computing technologies. She is actively involved in teaching, research, and academic development in engineering and technology domains. Welcome, ma'am. Would you please like to share a few words with us? So we'll be moving on with the presentations. The first presenter is Pablo Figueroa, presenting their paper titled A Dual Reactive Proactive Multi-Agent System for Personalized University Tutoring Using LLMs and RAG.
Good afternoon. The principal author, he can't present because he unfortunately don't know English. So maybe I'm the co-author, so maybe I can present the research.
Yeah, sure.
Okay. Okay. I'm pleased to present the research dual reactive and proactive multi-agent system for personalized university tutoring using LMs and RAG. In this solution was in university environment. So the problem was that in a university environment, teachers face a high demand for personal tutoring, and it's difficult to provide immediate feedback to a large number of students. And these students often have to wait a long time to resolve specific academic questions. And a manual tutoring process limit the constant support to require for effective learning. So the solution that was proposed was developed a multi-agent system based on LMs for personalized tutoring. And the idea was the system provides immediately and automatic feedback for the students. Especially agents in this system act as virtual tutors to answer questions to the students in all time. And it uses RAG technology to ensure that answers are based on official course materials. And these solutions compress the teacher's works by automating repetitive incurs. And this was proposed with two systems. We have first the reactive flow, and it was used the C4 model. And in this case, we have the reactive flow, and we have these agents, principal orchestrator agents that is manage the system workflow and distributes tickets and coordination the action for all other agents. And this system is interactive with the student. The expert agent provides deep domain knowledge and any specific topic request by the student. The support agent utilizes user provide documents to generate precise answers based on a specific context. And a generator agent responds for creating education content, maybe summaries or something like that. And evaluation agent is a specific agent, is designs performance assessments so the user can review and test the learned material. And I have the proactive flow, the second system, and it's have four principal agents. The first is analyze agent, and it extracts and analyzes the information and system it to configure file for following agents. The planner agent makes a planner to the student will going to do. And generation agents based on student data creates personalized content, summaries, and maps, and something like that. And recommended agent identifies advanced student to materials and recommendations for students who have met all the goals. And the technology was React, FastAPI, LangGraph, MongoDB, Supabase, and Mistral OCR. And the workflow was like this. The inputs were the system receives the agent state, which acts as the core data structure, and case fields instruct to LM's models names, IDs, and the user prompt. And the processing is managed interaction to have a to the students. And the agents was a filter agent that process a conversation to the student, match the student requires with their specific subject, determines if this requires a private read or needs more info, and creates an optimized search query for the vector. And expert agents have all the information to give a response to the students. The support agent use this agent communicate with the with the expert agent, and use RAG to have all the information. Evaluator agent is a specific agent for the evaluations, and that's it. In another system, proactive system, this creates the initial state with the use profile and history. Key files include the LMS model's name, session, user ID, and the user prompt. and it's check the plan. If it's not good enough, this system replies the strategy, and the system produces the final education materials, example summaries, maps, and that. And have these agents, agents, and it analyzes the history of the students, and then a planner agent makes a plan, sequence plan to programs learning plan adapted to quality student level. And then the evaluation agent compares the proposed plan, assigns the students objectives and profile, and AI classifies the plan's quality as good or bad. It tries a reply flag if the plan doesn't meet the student needs. And recommended agents check the current knowledge block and student learning and selects ideal format to the student, maybe summary, mid maps, or exercise. So that's. And last is generation agents that uses the RAG search results to ensure the content is based on official source. And the AI generates the final material, flashcard, GIFs, and a specific JSON format. And this is a video of the interface. It's a little example in how we use this. We have 10 Doland PDFs, and we have this information to make the question, to have the material, and that's it. And the evaluation was the reactive system evaluation was this, and the multi-agent architecture significantly reduced data intervention compared to generic models, achievement 94.2% accuracy in finding relevant information, and proactive workflow. The system successfully closed the pedagogical cycle: first diagnosis, then planning, then generation, and last delivery in autonomous and current way. And finally, the cost and sustainability, with an operating cost of only 14 cents for a student per month. The model is highly viable for massive implementation. In this case, was in a university. And the conclusion was the system achieved 94.2% accuracy in finding documents and 87.8% find fullness and answers, meeting high pedagogical standards. And single queries are resolved instantly, and complex study plans are generated in about 2.8 minutes in the background, and the students reporting a high satisfaction, highlighting a 4.8/5 score in time saving during the study sessions. And that was the research. Thank you. Do you have any question, madam?
Thank you, Miss. Actually, I would like to ask the participants, do you have any question here? No. It's okay. Actually, I have to say that this is very interesting topic, and I can see that you already built a system with multi-agent, right? So I have a question here related to proactive phase, right? Yes, you have that slide. Yes. So, previous slide.
Okay.
Proactive. Yes. In this case, actually, I have to say that um, truly appreciate your work here, but I would like to ask that if in this case, if checks the plan and if it's not good enough, the system replans the strategy. So, in your experimental um, experiment, so can you see many situations like that just based on
Like, okay.
yeah
So, situation like, okay, we don't have many users. Was
yeah
only maybe 10 users, and it was give us a good information, like good manuals, summaries, and we don't have many problems in this case. So
yeah
maybe with 100 students will have problems, but in the study we do, we don't have a problem like that.
yes thank you thank you
Thank you.
I have one question. Can I?
yes
Oh, sorry.
Yeah, yeah. In your topic, how does your system is compared to that traditional tutoring system?
Sorry,
In the your reactive and proactive multi-agent system, no? That how does your system is compared to that some traditional tutoring system?
okay. The idea was create a, maybe a chatbot that functionally every time, because teachers maybe can give us an answer every time. So the idea was automatization of manuals, PDFs that we when in my university we have, and the students maybe can't read this, or that they have no time to read this, and the teacher maybe have time to use this information. And the idea was use this information and exploit it
Only make some
to
adaptive.
sorry.
Um, okay. Okay. Yeah. Okay. Okay. No, no issue. Thank you.
Okay. Okay, thank you.
thank you
Thank you for the presentation. And
Thanks.
up next, we have Tanvi Bakhare presenting the paper titled AI-powered early dyslexia detection using webcam-based eye tracking, speech analysis, and adaptive learning, a multimodal review and system framework.
Good morning, everyone. I'm here to present our work on AI powered early dyslexia detection using eye tracking, speech analysis, and adaptive learning. Let me share my screen. Just a second. So this work is done by our team under the guidance of Professor Monali Deshmukh at International Institute of Information Technology, Pune. Dyslexia is often undetected at early stages, and our goal is to build a system that makes detection easier, faster, and more accessible. So the problem early detection of dyslexia is still a major challenge in school environments. Most traditional methods on expert based assessments, which are expensive and not non-scalable for large populations. Also, the assessments are often subjective and may vary between evaluators. Existing technological solutions usually rely on only one type of data, such as eye tracking or speech. They do not provide a complete picture. Another important limitation is that these systems only detect the problem but do not provide learning support. So, there is a clear need for low cost, scalable, and objective system that can both detect and support students. So, dyslexia is a neurological development disorder that affects reading, spelling, and phonological processing, even when intelligence is normal. It is especially challenging in multilingual environments like India, where children learn multiple languages. Traditional diagnosis methods are manual and time consuming, making early detection difficult. This is where artificial intelligence plays an important role. AI can analyze reading behavior objectively by studying eye environment, speech patterns, and interaction data. It allows real time analysis and helps in identifying patterns that may not visible through manual observation. This makes early detection faster, more accurate, and more scalable. The motivation behind this work come from real world challenges. Delayed diagnostics can negatively affect a child's confidence and academic performance. Many schools, especially in rural areas, do not have access to trained experts. At the same time, children respond better to interactive and engaging learning methods. So our objectives are to develop an AI based system for early detection, to use both gaze and speech data for better accuracy, and to provide personalized adaptive learning support after detection. References. So we have used paper of advanced machine learning methods for dyslexia biomarker detection by Osman Oal Muniadi, RC Omar K Muhammad through IEEE, which was published in 2021. Also, we have used eye tracking image encoding autoencoders for bridging language boundaries and developmental dyslexia detection for our research purpose. Proposed system overview. Our proposed system is a web based AI platform for dyslexia detection and intervention. It uses a standard webcam to track AI movements and microphone to analyze speech. The system interacts from both gaze and audio data. These features are processed during using machine learning models to predict dyslexia risk. Finally, the system also provides adaptive learning through game based activities to tailored for each student. System architecture. Now let's look at the system architecture. The system takes two main inputs, that is gaze data and speech data. First, the gaze is the data is pre-processed, for example, noise filtering and MFCC extraction for speech. Then we use two models, a CNN model to propose gaze heat maps and a XGB boost model to process tabular features. These outputs are combined using a meta-learning approach, which improves overall prediction accuracy. Finally, the system generates a dyslexia risk score. The multi-model approach makes the system more reliable compared to single modulator systems.
Excuse me.
Eye
Excuse
tracking
me.
module.
Yeah. Excuse me. Please, please show your full screen. So, because we cannot see details.
Okay.
Thank you.
Yeah. Are you able to see now?
Yes. It's okay. Thank you.
Okay. Uh, Coming back to the eye tracking module, it uses a webcam based approach, making it low cost and accessible. It captures key features such as fixation duration, saccadic movements, regression patterns. For example, the frequent regressions or longer fixations may indicate reading difficulty. This feature helps in understanding how a student reads and process text. Speech analysis module. The speech analysis module focuses on phonological aspects of dyslexia. It extracts features such as MFCC, which is the male frequency cepstral coefficients, which represents speech signals, prosody, English, including pitch and intonation, speech rate, and articulation clarity. These features help identify difficulties in pronunciation and phoneme recognition, which are common in dyslexia. Multimodal fusion. One of the key strengths of our system is multimodal fusion. Instead of relying on a single data source, we combine gaze and speech data. We use CNN for spatial gaze patterns, XGB Foost for structured data, a meta learning layer to combine outputs. This improves accuracy and robustness. Studies how that multimodal systems perform significantly better than unimodal ones. Adaptive learning system. Our system doesn't stop at detection, it also provides intervention. It includes an adaptive learning model with phonological awareness games, letter sound exercises, reading and comprehension tasks. This system uses reinforcement learning to adjust difficulty based on student performance. It also tracks progress over time and provides feedback to teacher and parents. This makes learning more engaging and personalized. Conclusion. To conclude, we proposed a low cost AI based system for early dyslexia detection. It combines eye tracking, speech analysis, and machine learning to provide accurate and scalable screening. It also integrates adaptive learning to support students after detection. In the future, we plan to deploy the system in real classrooms, expand to more languages, and explore federated learning for better privacy. Thank you for your attention.
Thank you. Thank you. So, I would like to ask the participants, do you have any question here?
How are
I
the
can.
how are your multimodal signals are integrated?
Multimodal. Just a minute. Huh?
Okay, my question is, if you had tried inventing a case with this system, and if you have some data regarding eventual testing with people with dyslexia and so on.
Mansha, you aren't really audible. Can you please share your question in the chat box? Until then, Tanvi, you can answer the question asked by Dr. Suryavanshi.
Yes. Thank you.
Our system integrates multiple modalities, mainly eye tracking and speech data through a structured pipeline and a fusion mechanism. Both the inputs are collected using a webcam and microphone. These are passed to the CNN model to be the outputs from both the models are combined using a meta learning fusion layer. This fusion step integrates the strengths of both modalities and generates the final dyslexia score.
Thank you.
Any more questions?
Tanvi, your screen isn't shared, by the way, in case you're trying to show anything on the screen.
Okay, I'll share my screen once again.
Yes. And the man Domenico has asked a question. It's in the chat box. If you
Okay.
want, I can read it for you. They've asked, did tried your system in clinical cases? Like, have you tried your system in clinical cases?
We are planning to try our system in clinical cases. We are in contact with the organizations. We have also we are also going for testing where we can test our system on students with all with ethical permissions and all. Just a minute. Let me just.
Hope that answers your question, Domenico. And if it doesn't, feel free to chat with Tanvi in the chat box. Session chairs, have your questions been answered, or are there any more questions?
Actually, I just want to ask that you already use the eye tracking speech analysis, right? So I don't know that you present some different speech analysis features, right? And FCC one. So did you check the effective of different features, or you compile all of them in your work?
Just a minute.
Yeah.
No speech have worked. Just a second. Can you repeat your question? Because of
Um,
no network, I couldn't hear that clearly.
it's okay. I just want to ask that you use some different features to analyze speech, right? For example, NFCC feature and so on. So my question is, did you use the different features in each case,
Okay.
or you combine
Uh,
all of in your works?
no, as mentioned in the PPT, we have been stick to all those features only. Apart from that, we have not used any other.
Okay. Yeah. So thank you. Thank you.
Thank you. Any other questions?
No, I don't have any question.
Thank you, Tanvi, for your presentation. It has been quite an engaging discussion.
Thank you.
Up next, we have Luis Anthony Hidalgo Ponce presenting the paper titled Artificial Intelligence in Predictive Analysis of Electoral Processes in Ecuador.
Good afternoon. My name is Luis Hidalgo, and I'm going to present the. 1 second, please.
Hello, झालं भाई.
I'm going to present artificial intelligence in the predictive analysis of electoral process in Ecuador.
व्यवस्थित झालं ना?
Okay. Artificial intelligence has transformed how we analyze public opinion in electoral context, moving beyond traditional tools that capture voter behavior using real-time digital data. Hybrid models can simulate the scenarios, microsegment audience, and automate political messaging. Though this also raises concerns around information manipulation and privacy. Analysis have evolved from traditional model to deep learning and transformer-based architecture, enabling more precise evaluation of public opinion by aspect and polarity. This study developed and compares three models: Beto plus LSTM, and Beto plus by LSTM, for aspect-based sentiment analysis of Ecuadorian electoral opinions collected from YouTube and Twitter. Okay, methodology. For this study, we applied the quiz ML methodology, which probably used with a structure process from start to finish. Well, business insight. First, we define the objective to gather public opinion on corruption, the economy, security, and others in the context of the Ecuadorian election. Data understanding. We collect the data comments in Spanish extracted from YouTube and Twitter related to the presidential candidates. Data preparation. We cleaned and prepared the text, and we removed noise, applied tokenization with BERT, and target the parse to speech using the bioschema. Modeling. With the data ready, we trained three models: Beto alone, Beto with LSTM, and Beto with by LSTM, under the same experimental condition to be able to compare them. And finally, we evaluated the performance of each model using precision, recall, and F1 score on an independent set. Well, this is the results. For the result, we evaluate the three models, and here we can clearly see the difference. Beto alone already performed well with an F1 score of 84.41% and precision of 84.47%. However, when we added LSTM, performance dropped slightly with F1 score of 82.35% and precision of 83.34%. The best results was achieved by Beto plus LSTM, reaching a F1 score of 84.51% and the highest precision at 85.09%. The bidirectional architecture allowing to better capture the complex political context of Ecuadorian discourse. Okay, best model, Beto plus by LSTM. In the performance graph, we see that the F1 score rise sharply in the first few epochs and they reach nearly 0.8 around epoch 4. Both curves, the training and validation curve, established between 0.83 and 0.87 wide with very little difference between them. In the loss graphic, we see that the loss drop rapidly at the beginning and stabilizes between epoch 7 and 9. Again, the two curves follow very similar trajectories. Confusion matrix. This is the confusion matrix for our best model. On the diagonal, we see the correct classification: 1,246 negative, 544 neutral, and 332 positive case classified correctly. Beto plus by LSTM reduces the confusion between neutral and negative to use 80, while Beto made 121 of that same error. In the Ecuadorian political discourse, that distinction is particularly difficult because the line between a neutral opinion and a negative opinion is very thin. Well, this is the dashboard. The Beto plus by LSTM model was implemented in an intuitive dashboard for a sentiment analysis based on aspect of whatever opinions. The frequency of analysis aspect highlights the most frequently mentioned ones. The sentiment trends use a stacked for chart to compare for each candidate. The proportion of positive, neutral, and negative opinion. Donut chart for the top three candidates show the sentiment distribution based on the largest number of analysis opinions. And the positive sentiment trend identifies the candidate with the highest approval rating. Okay, discussion. Our model achieved an F1 score of 84.51%, a result comparable to that Isnawijayani et al. And Indonesia, who obtained 80% by analyzing presidential campaigns on social media using BERT. We outperformed the studies in Latin America, such as those by Caceres et al. In Peru and Gudiño et al. In Brazil, both of which achieved 76.6, 60, 80% and use large language model like Llama 2 or for political analysis. We also performed Masum et al. In Bangladesh, who implemented BLF team for sentiment analysis in Bengali and achieved 79.09%. However, we acknowledge that there are studies that outperform use Srihisha and Chandana in India, achieved 94.70% with Roberta plus LSTM on a much larger dataset, and Xu et al. In China achieved 92.10%. The difference is mainly explained by the size and balance of the datasets. Okay. Conclusions. Beto plus by LSTM was our best model with an F1 score of 84.51%. Demonstrated that combining Spanish language transformer with bidirectional network is an effective strategy for electoral analysis. We integrated the model into an interactive dashboard that allows users to visualize sentiment by candidate, making it a practical tool for analysis research. Well, this is the reference, and thank you.
Thank you. So, do you have any question here? No. So I have a question. Actually, I don't know clearly about your data set. So please, could you explain more clearly about your data set? How large your data set, the way you collect data, how can you pre-processing your data? Yeah, because I cannot see it clearly.
Oh, yes, okay. The dataset, we collect data from YouTube and Twitter.
Yeah.
From YouTube, we use Selenium.
And
For Twitter, we use Twitter Harvest. YouTube comment were scrapped presidential debate videos and tweets were gathered using Twitter Harvest with electoral search term. For pre-processing, we remove short comments under 5 words, strip directories, converted text to lowercase, and apply verb-based tokenization. Sentiment levels, positive, neutral, and negative, were assigned using Pi sentiments and Robert Twitter, followed by manual correction to ensure cultural consistency in the Ecuadorian political context.
Okay. So actually, after that, you have three labels: positive, negative, and the neutral, right?
Yeah.
Yes. Thank you. I don't have any question here. Thank you.
So, how does your system is handle some ambiguity or some complex techniques? How you handle it?
Okay. Give me a second, please. Ambiguity is one of our main challenges, especially in political discourse, where the boundary between neutral and negative opinion is often very thin. Our veto plus bilateral STM architecture helps because it captures both past and future contextual dependence, which improves the understanding of ambiguous process. However, we acknowledge that sarcasm and irony are still difficult to handle. That is why we apply manual correction during annotation, and why future work include exploring more advanced transformer models and LLMs that are better equipped to deal with ambiguous political language.
Any other questions, Chair? Thank you, Louis, for your presentation.
Thank you.
Thank you.
Next, we have Madhuri Survase presenting the paper titled Comparative Evaluation of Commercial ASR APIs for Specialized Domains, Performance Analysis, Limitations, and Future Directions. Madhuri Survase, are you here with us? Madhuri?
Hello.
Hello.
Hello. Am I audible?
Yes, you're audible.
Ma'am, may I know at what time is the schedule planned for my presentation? Means, Miss Madhuri's presentation. Actually, I am a co-author.
It is right now.
At 11:30.
Yes.
Hello.
Yes.
Okay. Ma'am, can you give me just 5 more minutes? I'll just make a calm place. Actually, Miss Madhuri and I were supposed to give the presentation. Just 2 to 3 minutes so that I can arrange myself in a calm place.
Yes, take your time. We'll take the next presentation right now, and then you can do it
Okay.
afterwards. All right.
Okay. Sure.
Next, we have Nurul Istiq Faro presenting the paper titled Developing Augmented Reality Using Assembler Edu to introduce the alphabet to dyslexic children in elementary school. Nurul Faro, are you here with us? Nurul Faro? Okay, we'll be moving on with the next presentation. Next, we have Seda Zena Rohana Sneha presenting their paper on energy consumption trend analysis from smart meter data under big data tools.
Hello, am I audible?
Yes, you're audible.
Just give me a minute. Can you all see my screen?
Yes.
Yes.
Good afternoon, everyone. My name is Soida Zaina Rohana Sneha, and today I would like to present our research titled Energy Consumption Trend Analysis from Smart Meter Data under Big Data Tools. My co-authors are Mohammad Samsul Arifin and M.M. Musharraf Hossain. We are from Department of Computer Science Engineering from Bangladesh, Chittagong University, Engineering and Technology. And our paper title is 463. These are our presentation outline that we are going to cover today. Smart meters are modern devices that record electricity usage in real time and generate large-scale data. This data is very useful for energy forecasting, monitoring, and demand analysis. However, real world smart meter data is often noisy, incomplete, and contains abnormal values, which makes analysis difficult. To handle such large and complex data, big data tools like Hadoop and Apache Spark are widely used today. In our work, since real smart meter data is often private and not suitable for large-scale testing, we generated a realistic dataset with 10 million records. We then performed an end-to-end data analysis using Spark, including processing and prediction modeling. So these are our relative work. I'm not going to try explain all of this, but I will try to just say the study gap that I have found in these works, which are they only focused on forecasting or anomaly detection, but they did not fully utilize the preprocessing or did not use any big data pipeline. And most of the cases, they have used a small data set. And some of them have used a limited data set limited to a single household data set. So they have not used any distributed big data processing or storage. So which is why what motivated us to build a scalable big data pipeline. We analyzed 10 million smart meter records to identify consumption patterns, peak usage behavior, regional differences. And we have predicted electricity usage using a machine learning, which is linear regression, and detected anomalies using unsupervised learning. This is our system architecture. For the experimental environment, we have used a virtual machine, Oracle VirtualBox, Kali Linux OS. Then we have tried to generate a 10 million record dataset, which is Python based, and the dataset has smart meter ID assignment, and we have injected anomalies and noise. The dataset was created chunk based. After creating the dataset, we have stored it in a Hadoop distributed storage layer, which is HDFS. And our replication factor was only 1. We have only used a single node. And for block size, we have used the default boxes, which is 128 MB. After creating the dataset, we have converted it into Perquets to be able to preprocess it by PySpark. For the data processing using PySpark, we have removed the duplicates values, missing value interpretation, outlier detection, and other analysis that are required for feature engineering and prediction. After that, for feature engineering, we have used feature vector assembly and scaling, min-max scaling for normalization. Lastly, for prediction, we have used a linear regression model, and we have tried to forecast energy consumption, and lastly, anomaly detection. So this is our dataset. We have 12 features. Our dataset size is 10 million. We have generated using Python script, and the size of the dataset is 800 MB plus, which actually simulates real-world smart grid data. In the right side, we can see the table which contains the attributes of the dataset. So this is the block, the HDFS block distribution for smart meter dataset. We have in total 7 blocks. 6 blocks is of one size 128 MB, and lastly the block 6 is of 64 MB. For the distribution, we have used distributed processing. We have used Apache PySpark. The raw smart meter data was first converted from CSV to Parquet format to reduce storage size and improve processing speed. For the pre-processing step, we have removed duplicate records based on meter ID and timestamp, handle missing values using mean imputation for numerical features, detected and removed outliers using the IQR method, and applied feature scaling like the min-max and standard scaler for better model performance. For feature engineering, we have created new features like hour, day of the week, and month. We have used vector assembler to combine the electrical features, environmental features, and temporal features, and perform aggregation to analyze energy usage across regions and tariff categories. For regional analysis, we have computed the average consumption, where we can see in the table that Chittagong, which is a region in Bangladesh, has the maximum average consumption, which is 0.182. And Rangpur is also another region in Bangladesh, which has the lowest average consumption, which is 0.181. Next is a tariff analysis. We can see that the peak usage has the most average consumption, which is 0.260 kilowatt, and off-peak has the lowest, which concludes that electricity consumption during peak hours is almost 2x higher. For the hourly consumption patterns, we have seen the moderate usage in late night and daytime from hours to 12 a.m. to 5 a.m., 9 a.m. to 5 p.m., and 10 p.m. to 11 a.m., where we can see that there is moderate usage. And in morning peak from 6 to 8 a.m., there is the consumption is high, because most of the time we start our daily activities in this time. And evening peak from 6 to 9 p.m. we can see the highest usage at home. So we identify peaks by comparing hourly averages. Morning and evening are highest because more household activities happen during these hours. For machine learning model, we have used linear regression. For input features, we have used the hour, day of the week, month, voltage, current, temperature, humidity. As output, we have used the consumption, how much consumption the users consume. For training and testing, we have splitted the training and dataset into 80% training and 20% testing. This is our model performance, where we can see that RM SE is 0.0141 and R2 squared is 0.9891. And in the right side, we can see the predicted and versus the actual consumption. As we can see, that predicted value is very closer to the actual consumption. That explains that our model actually performed very well. For the anomaly detection, we use K-means clustering to identify unusual electricity consumption patterns. Each data point was grouped based on similarity, and each distance from the cluster centroid was calculated. Data points with a higher distance from the center were considered abnormal. A threshold was set using the 99th percentile of distance values to detect anomalies. Points above this threshold were labeled as anomalies, like 1, and other was normal. Conclusion and future work. This project developed a smart meter data analytics system using big data tools. A dataset of 10 million records was created to simulate real-world conditions, including noise and anomalies. The dataset was pre-processed using Apache Spark for efficient distributed processing. Linear regression model was used to predict the electricity consumption, and it gave good results with RMSC 0.041 and R2 square of 0.89891. This shows that big data and machine learning together can handle large-scale energy data effectively. In future, this work can be improved by using deep learning model, real smart meter data, and real-time data processing, and it can be extended to larger distributed systems used for applications such as energy forecasting and theft detection. These are our references. Thank you.
Thank you. So I would like to ask the participants, do you have any question here? No. So I have a question for you.
Yes, please ask.
Yeah. I can see that you already show your system architecture with many phases, right? And
Yes.
yes, with the phase number 6, machine learning and prediction. So I just want to ask that why you just use linear regression model. And how about the others?
Okay.
Yeah.
So I wanted to start off with a simple model. Linear regression is very simple and interpretable. So I wanted to see how our dataset can perform, how better it can perform with a simple model. In future, we would like to go with deep learning models and other models.
Yes. So based on your knowledge, do you think that you use a k-mean clustering method in order to divide your data into different clusters, right?
Yes.
And can you see the result here? This is very good, very suitable for your situation. The meaning of clusters.
Yes.
Yes, here I can see that category you already give that, right?
Can you repeat the question? I actually didn't get it.
Yes. Here I can see you use k-mean clustering method in order, to detect unusual pattern, right? Yeah. So actually you already give here some different situations, different clusters, right?
Yes.
Yeah, so can you see this is very suitable comparing to real life situation here?
Yes.
Okay. Yes. So it's okay. I just want to understand that the result you use an machine learning model to detect something, and we can explain by kind of daily activities situation, something like that. So thank you.
Yes.
Yeah.
I have one question. Is any limitations to the users?
Hello?
Limitation is there?
I didn't hear you properly. What?
Is there some user limitations is there?
User what?
User limitation of user.
Not limitation. We have created the synthetic data set, 10 million records.
But in your paper, in the abstracts, you can mention here only 35 users are in your abstract, in your paper.
Basically, we created a data set because in our country, the smart meter data is not publicly available. And to create it, we used an AI tool to create a 10 million records data set.
Okay. Thank you.
Hello.
Are there any other questions?
What?
All right. Thank you for the present. Hello? Is anyone trying to speak something?
Do I need to stop my sharing?
Yes, yes.
Okay, thank you.
Yes. Thank you for the presentation. And now we have Madhuri Sarvase presenting their paper titled Comparative Evaluation of Commercial ASR APIs for Specialized Domains, Performance Analysis, Limitations, and Future Directions.
Hello, am I audible?
Yes, you're audible.
Yeah. Will you please allow me to share my screen?
You can directly share it.
Okay. Screen. Okay. Hello, is it visible now? Is my screen visible now?
No, it's not shared.
It's not shared. Okay.
No.
Yeah, there were some settings that I have to make. Just please let me know. Okay, entire screen. I have shared my entire screen.
Yeah,
So
it's visible.
yeah. So can you see the first slide?
We can. Can you please put it in landscape orientation?
Yes, yes.
Also try to maximize the screen.
Okay, just one sec.
Yes, perfect. Thank you.
So today I'm presenting my research about comparative evaluation of commercial ASR APIs for specialized domains. So what were so presentation agenda will be as below, that I'll be introduce the domain and what motivated us, then the ASR APIs, what evaluation methodology we used, then the results that we found on clean and the forensic audio, means the audio which is having some noise, and some domain specific challenges that we observed, and speaker personalization performance of these domains. So, and we'll discuss these results and I'll conclude. So what is ASR? So automatic speech recognition converts spoken language to text. So it powers virtual assistants, accessibility tools, and real-time transcripts. So the currently available ASR systems which we have are can process that speech spoken by a human, and they process it along with the noise and then convert it to the particular language, means for English, for Marathi we have tested. So the recent advancements in this field are the near human accuracy on clean audio via the deep learning models, and the transformer based architecture have been observed. Whisper, wave to wake, Hubert are using these technologies. So critical limitations that we observed in this study are the forensic audio, means there were degradation in performance under noise or the overlapping speech. Then there was we observed no native support for mathematical and Greek letters, mathematical symbols and Greek letters. So it is difficult for the scientific reports or mathematical reports to get edited using only speech. We have to use keyboard-based inputs in that case. And then the human personalization mostly refers to the accent and dialect bias. So current models are not able to identify it. And the modularity loss when end-to-end architectures limit the flexibility of domain adaptation. So I'll explain these limitations, how we have observed. First, let me start with the methodology. So we used these 14 systems as listed here, that Google Cloud Speech to Text, then Microsoft Azure Speech, Assembly AI, DeepGram, SpeechMatrix, IBM Watson Speech to Text, Amazon Transcribe, then OpenAI Whisper, Hubert, then WebKit, and Vosk. Vosk is the open source thing. Remaining out of the above, most of them are having subscription-based systems. So the free subscription part, which was allowed by the first login, have been used by us, and we used their APIs, and we kept the single set of single strings. Okay. So for the clean audio, which we have used in a CAM, the iPhone recordings, 37 words were phonetically diverse dataset have been used, which was created in using iPhone, and in a CAM environment, we have recorded those, and same recording was played for those APIs to detect the text. Then there was a noisy environment which was put, and in that noisy environment, we repeated the same set of sentences, and we checked the performance of detection. And for Greek letters and mathematical symbols, we created some sentences which involve the mathematical expressions, and Greek letters were used. The simple E is equal to mc square kind of equations were used for this domain specific challenge. And there were we tried all these things with different users also. So that different users means a male and female dialects were tested, and students having different accents, they have to speak some few of the words, and we check the accuracy of detection. So metrics was, the primary metric was word error rate. So how many words were given to the system and how many of it have been identified correctly was the word error rate. So insertion, deletions, substitutions were allowed divided by total words. So word error rate. Then secondary was the accuracy of that system. Then precision recalls, and version variability was there. And statistically, so error distribution and the robustness assessment have been completed. So as we can see the results, so for clean audio, the word error rate for all these systems means Google Cloud, Microsoft Azure, Assembly AI, DeepGram, WebKit have been shown here. So Microsoft Azure, Assembly AI, they are having very high accuracy in clean and for the clean audio. So 97.3 up to 100% we have observed for the clean audio thing. Accuracy is more, and word error rate is almost zero in for these cases. For forensic audio, means where the audio is not clear enough, the performance is little bit degrading. In case of Microsoft Azure, it is degrading to a very high extent, means from 97 on clean audio to 18.9% on forensic audio, it is showing us. Sorry, the disturbance. Actually, I'm giving the presentation from my phone, so please pardon me for that. I think I have to take this one. Ma'am, can you please allow me a single minute? Hello. So thank you. Sorry for the interruption. I'll be continuing my presentation. Okay. So OpenAI, as we can see, OpenAI Whisper is also has shown the degradation in the performance. So but what we can see here is the performance visualization of clean versus forensic audio. As we can see here, the Google Cloud, MS Azure, and WOS are showing very degraded performance on forensic audios. Hello, am I audible or still is it clumsy? So domain specific challenge, for the domain specific challenge, we tested the Google Cloud Speech to Text and Microsoft Azure. And the custom vocabulary was used for that. And the custom language models have been used. So I come to the speaker personalization thing.
Yes.
Hold.
Training.
7-3. हॅलो मॅम बंद कर सांगून टाकते बंद करा म्हणून सांगते ते प्रेझेंटेशन कॉन्फरन्सचं ऑनलाईन आहे थायलंडची कॉन्फरन्स हो म्हणून सांगते बंद करा म्हणून हा हॅलो मॅम hello can you hear me?
Yes.
Hello. Yeah, ma'am. There is a call for me to attend an AICT approval meeting. Can you please reschedule my presentation? I'll give it properly after half an hour. Hello. Hello. Hello, ma'am.
Hello. We here.
Yes, ma'am. Yeah. So can you please allow me to give my presentation after half an hour? I have to attend an AICT meeting that is also in virtual mode, but I have to present some data to that meeting.
Means that you will come back later, right?
Yes. Yeah, I'll come back later and give the presentation again. Okay?
Yes.
Please
Okay,
allow
okay.
me, ma'am. Yeah. Thank you. Thanks for your cooperation. ma'am.
Madhuri,
Yeah.
actually, this session will be concluded by them, so you can join the next session.
Next session.
Yes.
And it may I have that link for the next session because
it
I
will
was
be-
in the virtual room 2, room B.
Yes, it will be shared just in the chat box.
Okay,
Just
okay.
wait for 5 minutes.
Okay, thank you.
Yes.
Next up, we have Tirupati Rao Dokara presenting their paper titled Harmonia A, a pluggable risk-aware data sharing framework with continuous compliance, provenance, and machine unlearning design and proof of concept
Myself, Dr. Trupti
blueprint.
Bansode, sir. I have completed my PhD from Shivaji University in 2024, and currently I'm working as a PG coordinator.
Yeah. Can I go ahead, please?
Yes.
Yeah. I'm sharing my screen. Please let me know once you're able to see my screen.
It's visible.
Yeah, thank you. Good day, everyone. Thanks for this opportunity to present my research paper. And I'm Tirupati Dokra, a research scholar in Chandigarh University. Almost 7 papers I published, and recently one of my papers, which was published in the scientific research, is one of the main framework and design in the field of AI and data. And I work with Professor Manisha Malhotra, and I'm an industry leader for the last 27 years. I head I'm a chief architect executive, and I head the R&D Center for Scientific in products and platforms and AI. Scientific is one of the top companies leading the innovation in the AI products and platforms, agentic AI and other products. And we work with NVIDIA and other global partners very closely to further our innovation. And all the complete, architecture, R&D, so the divisions, ahead. So this is a brief about me. And today I'm here to present, Harmonia, a pluggable risk-aware data sharing framework with continuous compliance, provenance, and machine unlearning. I did not say machine learning, I said machine unlearning. Why I said machine unlearning is, machine learning is easy, though there is a challenge second, but unlearning is important in the changing global scenario. For example, when you talk about the compliance, right? The regulatory compliance are changing very frequently as yearly or half yearly or quarterly, based on the dynamics of the international globalization. So an entity within a certain geography has to adhere to the regulatory compliance and other voluntary the compliance norm. So how a model, if you're using an AI model, which you're trained to, understand the regulatory compliance and enforce it and assist you in implementing that, has to unlearn something to learn something new. Okay, so unlearning becomes very important. And as of today, there is no concept of doing it very easily of what part has to do. We may have to end up in training a model or fine-tuning a model. I don't know, most of the sections I've seen, people are using the out-of-box, the available base LLMs and all. So that is not the way the industry moves on, because they are too much wide in their scope and the hallucinations. And if at all you fine-tune, fine-tuning the base model would require somewhere around $10 to $15 million or $20 million of data being the major part of it. Okay, then if you have to unlearn and learn again, you may have to invest the same effort and money again. So this is where the framework comes in. And I would just see there are the gaps, basically, data becomes the key in our sustainable AI. And how do you manage and, ensure with the trusted data? I mean, Harmonia, tells that, how you can harmonize, reduce the cost, and, share the data with the total controls. And it suggests a 3-plane architecture to do that. The basic gaps which is, identify is the, these are the compliance rate, no clear, revocation, the auditability and sovereignty. And so these are the gaps, how do you, make over and work on these gaps? And my research objectives were on that basically. And if you look right, the core contributions of Harmonia, where it comes with a 3-plane architecture. The 3-plane architecture will tell you, how do you control, how do you enforce these policies, and how do you, deliver it, release it, the 3-plane architecture I'm gonna, talk about, and the risk-aware release collection. That means you understand when you're sharing the data, or releasing the data, you understand the risk involved at the other end. There's a lot of, globalization regulations like, data residency, local regulations, which get, enforced at a time, and whom you're releasing, it's a competitor or it's a, entity which complements your business, a partner in your ecosystems. It all depends upon whom and what and when you're releasing this data becomes very important. And the continuous compliance with the proof of evidence that you're meeting the compliance and the trust enabling which reduces the risk and the regulatory, law enforcement agencies, coming strong on you, which may affect the entity's credibility as a whole. Economy is a different thing, business is different thing, the credibility is the one of the most important things. And how the revocation and machine unlearnings, how do you unlearn what you have learned? Today you might be permitting something, tomorrow you may not be permitting. Tomorrow you may not be permitting, today you have to permit something, or in a very different way. How are you gonna do that? That is how, these machines need to know when to unlearn, when to learn. And that has to not to be done from the scratch again in a classical way. I think that is where the framework introduces the beauty of learning and unlearning with, just a policy based and configurable framework and the proof of concept and the blueprints. Okay, that is where the Harmonia is designed and the contribution speaks about. The governance and the control and the data plane, I was talking about the three-plane architecture. First, you set up, the identity trust, authorized based access control, the risk analyzer. You give the policies and all the policies, rules, and constraints which need to be enforced. And the engine, understands based on what you do, gap analysis. It interacts with you to see whether your requirements and policy has some gap. And once we concur, that is, taken into the place. So the governance is again an intelligent interactive base, like we were talking about, we have something known as HMI in the automation field where, the human to, machine interaction. So we are talking about HAI, the human to AI interaction at a level of HHI, that is human to human interaction level. So the governance plane is set up, and then the control plane, where of course this orchestration, what orchestration is talk about the virtualization, the need for data centralization is not needed because not feasible also because of the data localizations and presidency and many other regulators not willing to share their geographical data to other geographies or physically locate them. So how do you do the federated learning at their places? How do this complete orchestration work based on the policy and that risk analyzer enforcement and the mechanics of transformation, right? How do you preserve the privacy? Okay, the data privacy and all other, requirements, masking, encryption from what is needed in the security data. So all that, the mechanics of doing the transformations and ensuring the data is not, anonymized, we call as anonymized data where, it is not shared. And the proven services with the complete of, they provide a evidence-based backup to whatever is enforced. It is not like it is enforced and why it is enforced, how it is enforced, what is the proof that is enforced. Okay, the complete auditable and complete observe and monitoring for, gaps and surveillance in real time. So that is the control plane talks about, and exactly the data plane where we do connect the storages and the streams, APIs, release channels, and how do you, this data is consumed and, transmitted or served actually. So that is the complete. So normally in today's world, you see, right, people are not talking about the first plane, which is the governance plane, and seldom they speak very less about the control plane. And mostly whenever they talk about data sharing, they talk about the data plane. The data plane is obvious, it is required, but it may not be possible. It may introduce challenges, risks, and a non-compliance in aspects. So the governance and control plane, that with evidence and a complete control policies, which can change from time to time in real time. Okay, where the policies can be revoked in real time. Okay, not why, because today you have to deploy a model by unlearning something or learning something. It takes its own time, but if something has to be done in a real time overnight based on the enforcement, how do you do that? So that is where the Harmonia comes in and, does its research and objectives. So what we are talking about if you look at the risk aware, right, from the raw export, okay, to the mass data, to anonymized data, to the privacy sanitized data, synthetic data. That means you're not sharing the original data based on the risk. Okay, but the learning has to happen. So learning has to happen. It may not require the factual data, revealing the identity and the structure, but it may require a mirroring of the data, actual mirroring and cloning of the data without revealing any facts about the actual data. So that is where the synthetic data comes in, which can be cloned digitally without the factual thing. And the query only mode and the federated learning. That means even the model is learning. The data is not moved to a centralized point, and the model can learn locally where the data is, and only that intelligent weights, which doesn't carry any data or any risk, can be transmitted back to a centralized model, which can derive the intelligence about it in the AI. So this is what the basic the framework talks about. And if you look at how that happens, right? A request to the data. You evaluate the request with your policy engine of what is the risk and what you can do, what you can share, what you cannot share. If at all you're sharing, how do you share, and all that enforcement comes into. And the actual transformations happen. The release happens with a point-to-point security, complete, the runtime and, the security at rest and runtime is taken and continuously observed. And if something has to be revoked at a point, that can be revoked, the access can be revoked, and it can be controlled further. So that is what the Harmonia gets in with a real-time configurable interfaces enforcing the complex and, governed architecture to be taken care on at the platform level. Okay. So the revocation mechanism,
Excuse
how it
me,
works and where
sorry to interrupt you. This is
yeah.
just a gentle reminder that 1 minute is left for your presentation. So kindly conclude.
Yeah, I'm just concluding actually. Okay, so this is what I just spoke about, and the proof of concepts and the blueprints. We have done it in a policy and trust, the API gateway, and this framework has been actually implemented and tested with comparison, load, security, and all those experiments, and the data has been done, and the framework has been evaluated against the others, and these are the few of the results. Where we could see that, and the implication, limitations, and the deployment reality, and what we have done already, what is still remains to be done, and in a further better way. So we have just, left it for the further research work to carry on. And this is where, my, presentation, concludes. Apologies. Am I audible? Yeah, I'm done with the presentation. If any questions, I can take, else I can talk.
Session, do you have any question?
What is the risk aware for that data sharing?
What is the risk of contact data sharing? Is that the question?
Yeah, means what is the risk aware for that in data sharing?
Okay. The risk in data sharing is, first of all, is the data privacy, which is by default and de facto is the law of every geography. The second is, leaking of the, financial criticality data. Okay, like your credit card numbers, bank accounts, and other things. The third is the regulatory enforcement of the data residency and localization rules, where if you're sharing the data to an entity, that entity does not belong to the same geography and it is not being used at the same geography, there is a huge risk involved. Okay, broadly, these are the three risks of sharing the data. And again, other risks are the transmission of the data where, the hackers need to be protected and it need to be a secure transmission from the point to point when the data is being in runtime at the dynamics of the data at runtime and its rest has to be taken care of.
Okay, and what is the in any disadvantages in your topic?
What is the question? Can you come back?
What is
Any disadvantages?
Is any disadvantages in your harmonium?
See, the harmonization, it comes with a greater advantage of removing the need for a centralized data, platform for AI learning. Because most of the institutions you look today, they are creating a data command center for creating the data intelligence. That comes in, and it is more, on demand and green, okay, and more secure to where the edge policies can be enforced. Okay, so the harmonization, one risk, if I can say, that it computes everything dynamically. So a bit of latency could be there, compared to a centralized data platform which keeps everything locally. Otherwise, it is all, positive about mitigating all the challenges around.
Thank you.
Was I able to answer?
Yes, sir. Thank you, sir. Yes.
So any other questions I can take up?
I think that's it for the questions. Thank you for your presentation.
Yeah, thanks a lot. Have a great day all, and thanks for giving me this opportunity. Thank you.
Next up, we have Mohammad Shahidul Islam presenting the paper titled Machine Learning for Causal Inference on AI Adoption.
Well, hello. Do you hear me?
Yes, you're audible.
I'm sharing this slide. Can you see my slide?
Yes.
Okay. So first of all, thank you so much, everyone, to attend this international conference. My research title is Machine Learning for Causal Inference on AI Adoption. I'm the presenter, Faculty of Science and Engineering, Bangladesh University of Business and Technology. My co-author is Ronami Chandra, who is the same institution. So these are the agenda that I will present in my presentation. Introduction, data review, research gap, objectives, methodology analysis, discussion, results, and final the conclusion. So these are the introduction. So mainly, I'm using farm productivity related data in Europe for artificial intelligence adoption. So artificial intelligence is becoming a key driver of the transformation in modern farms. It is shaping how business operate, improving efficiency, automating process, and enhancing decision-making capabilities, which ultimately influence productivity. In Europe, farms have actively adopted AI technology in various areas such as supply chain management, data analysis, and strategic planning. But the thing is that despite this rapid adoption, an important question remains: does the AI actually cause productivity improvements, or is it simply associated with farms? So our one major challenge is this selection bias. Farms that are already more productive or better managed are more likely to adopt AI, which makes it difficult to isolate the true causal impact of AI productivity. So why actually causal machine learning? So from this figure, actually you can clearly see that the machine learning actually focuses on the prediction using correlations, while causal inference identifies cause and effect relationship. Causal machine learning actually combines both enabling reliable cause estimation while capturing complex and heterogeneous patterns. So actually combine the causal inference and the machine learning techniques, so which is known as the causal machine learning we apply for our artificial intelligence. So these are the actually literature review from where actually we will get the idea about our research. So this literature review actually tell us about the frameworks in economics and applied econometrics models, methods addressing heterogeneity and selection bias, heterogeneity and non-linearity, dimensional data analysis and prediction, machine learning for causal forest critical evaluation of existing studies which find out the causal identification and heterogeneity effects, integrated econometric and machine learning frameworks. So actually, these are the main literature review that we study for our research and find out the concept about our research. So these are the research gaps that we find out from our literature review. The first one is the endogeneity in AI adoption decision, which actually represent that firms with stronger management capital and digital capabilities are more likely to adopt AI, making model identification difficult. And the second one is limitation of traditional econometrics model, and then insufficient modeling of heterogeneous effects, prediction-oriented machine learning-led model interpretation, and finally, actually, we find out that the lack of an integrated model machine learning framework. So these are the mainly the research gaps that we found out from the literature review. So these are the main objectives of our study. The first one is to estimate the causal impact of AI adoption and farm productivity, and then develop an integrated causal machine learning framework. So these are the main two objectives for our study. So these are the main methodology. The table one actually this overview the experimental design and the model configuration. So actually we use the data source, which is we collect the data from orbits, from level. This data actually mainly we collect from the Europe from 2010 to 2023, and our mainly the outcome variable is labor productivity, total factor productivity. For the primary purpose, actually, we use the labor productivity, and for the robustness, actually, we use the total factor productivity. Treatment variable, we use the air adaptation, binary plus intensity index. Then, actually, we apply the econometric methods. Traditional econometric methods, we applied like orderlistic score, well as speech defect, differential and difference instrumental variables. And then actually after that causal machine learning methods, which is actually we apply here double machine learning, AT estimation, and then we use the causal forest KT, which is for the heterogeneity analysis. And then we use some techniques for validation, such as the placebo test and pretrend analysis. So these are our main methodology that we used in our research. Okay, so these are the analysis and discussion section. The first table 2 actually shows the descriptive statistics on the farm level variables. So from this table actually clearly see that the substantial variation in productivity from site and capital intensity across farms, AI adoption is relatively moderate, indicating that actually not all farms have adopted AI technologies. Okay, so the wide dispersion in variables such as labor productivity and farm age, highlighting heterogeneity in farm characteristics, supporting the need for causal and heterogeneity effect analysis. So actually all the farms are not the same having an effect for AI adoption. So these are the analysis and the discussion. Okay, so table 3 actually represents the robustness of AI, productivity effects across econometric models. And the table 4 represents the double machine learning estimate of the productivity effect of AI adoption. So actually, for table 3 actually represent the traditional econometric models like a wireless fixed effect, PID, and instrumental variables. And for table 4 actually it represents the double machine learning methods. We use here machine learning methods. So actually, and the figure actually shows that pretend and placebo test for AI adoption. So from all the results, actually we can clearly see that AI adoption has a positive and significant effect on farm productivity. And comparatively, the double machine learning method actually shows the robust average effect of about 4.5%, which is comparatively more than our traditional econometrics model. So the insignificant placebo and pre-trained test further support actually the validity of this causal findings. So this the table 5 shows the forest estimate of heterogeneous productivity effect of AI adoption. This is the heterogeneous productivity, so that's why we apply the CATI distribution, and the figure 2 shows the CATI distribution of conditional labor with many effects. So from the table and from the figure, actually, the results actually reveal that the significant heterogeneity in the productivity effects of AI adoption, while actually the average effect is around 4.5%, and the distribution is right skewed. So, which indicates that some firms gain substantially more than others. And higher impact are observed in ICT, large firms, and those with strong human capital and digital maturity. So this highlights that AI benefits depend on firm characteristics and complementary capabilities. Actually, not all the firms actually have a high effect for the artificial intelligence actually. So I mean, these will only depend on the firm characteristics and the complementary capabilities. And these are the actually comparison of econometric and algorithm machine learning approaches that actually applied for our data. From actually the first column actually represent the aspect, primary estimated treatment effect heterogeneity, functional form. So these are the actual criteria. Limitation also actually we perform here according to the different methods, traditional econometrics method and double machine learning method and the golden forest. So actually from all the results, we can clearly see that golden machine learning methods, especially golden forest, actually outperform a traditional econometric model by capturing heterogeneity nonlinear relationship and providing more accurate and insightful golden estimates. This is the comparison for all methods. So this is the conclusion actually. So this study actually provides golden evidence that AI and automation adoption significantly increase from productivity in Europe. And this findings actually underscore the importance of a complementary investment in skills and digital capabilities and demonstrate the value of causal machine learning method for analyzing complex technology adoption effect. Yeah, so thank you so much, John. If you have any question, please ask me.
Question chairs, do you have any questions?
Actually, no, I don't have any question here. Thank you.
Thank you. Can I ask some? Actually, in
Yes,
methodology,
please.
in methodology, that component of data sources you have to write it there orbis with you claim. So why did you merge this both orbis with you claim in a methodology?
Yeah, from the data source. Yeah, actually from Orbis actually we'll get the available data. That's why actually we collect data from the Orbis. Farm level data is available.
For data collection.
Yeah.
Okay. Okay. Thank you.
So
Thank you for your presentation. Next,
okay.
we have
Thank you so much.
Soumya Kuvelkar presenting their paper titled SkillBiz, a social media app for local businesses and skill services.
Good morning, everyone. We are here presenting our SkillBiz, a social media app for local businesses and skill services. Good morning, everyone. We are presenting SkillBase, a social media app for local businesses and skill services. We have developed an app, SkillBase, which connects local businesses, skill services, and customers. Problems in the current market. First, struggling for visibility. Second, resource constraint. Third, invisible talent. Why current solutions fall short? Current digital platforms were not built with hyper-local needs in mind, creating significant gaps for small businesses and service providers. Platforms like Instagram, Facebook, WhatsApp businesses, Google Maps, Just Dial, or other standalone websites still have limitations. Introducing SkillBase, the hyper-local marketplace. It features first role-based system, second hyper-local social field, third digital profiles, fourth community engagement, fifth trust-ready architecture. Literature review, foundations for SkillBase. Our platform's design draws upon extensive research into hyperlocal dynamics, digital platforms, and service-oriented architectures. These studies helped us build user-friendly and scalable system. How SkillBase works? First, there is a registration plus role selection. Then comes the access to location and generating feed. Then comes the post updates and interactive engagement. System architecture. Our system has three main parts: the client side or the front end, back end or the server side, and data layer. The front end architecture is built using React Native with Expo framework, React Context API for state management, Expo router for role-based navigation, TypeScript for type safety. Backend services, we have used Supabase as it is BAS functionality, Postgres with PostGIS extensions, real-time features for live updates, and JWT tokens with RLS for security. Authentication system. We have the sign up, login, and password recovery features. Once the user logs into our launches on our app, they have to either create an account or log in through or if they are already registered, then they have to just log in through their credentials. If they are a new user, they have to write their name, email address, then a verification code will be sent onto their registered email ID. They have to enter the registration code and then their account is verified. The interface uses modern designs elements like class effect inputs built for consistent and user-friendly experience. The three user roles. Firstly, after launching the app, the user has to go through a registration process and then select the role as either a customer, business owner, or a service provider. If it is a business owner or a service provider, they have to upload and verify their documents on the app, create business or service profiles, upload post, receive booking request, and scroll and interact through the app. If it is a customer, they simply have to verify the email, then grant location permission, create profile and page, and scroll through and interact in our app. Business owner profile setup. Once the user selects the role as business owner, they are asked to fill in their details such as business name, category, description, business address, and contact details. After this, they have to go through a verification process wherein they have to enter Aadhaar number, GST number, and business license number. Verification helps build trust between customers and businesses. All verification information is securely stored for identity confirmation. Service providers profile setup. If the user selects the role as service provider, they have to enter the details such as service name, service category, description, service location, and contact details. They also have to go through a verification process, such as they have to enter the Aadhaar number and police verification certificate. Verification helps build trust among customers and service providers. All verification information is securely stored for identity confirmation. Settings, business, service, and customer profile pages. All the profile pages are uniformly dark themed profile pages. Here is an example of a business profile page wherein it displays the business name with profile image, then location with map interaction, brief description of business, working hours, along with key metrics such as ratings, followers, and reviews. It consists of a follow button and messaging feature. There is post and review toggle section. This is an example of a service provider, which displays the service name, the profession, location with map integration, along with key metrics such as ratings, years of experience, and reviews. There is also messaging and calling feature. Then there is a about section, price range, and service availability. There is a toggle between photos and reviews. This is an example of a customer's page. And this is a settings tab, wherein the users can edit their profiles, change their account preferences based on themes, notifications, and language. They can change their passwords. There is a logout button and other features. Category filter and pinning, following review and rating section, and chatting features. We can pin the categories onto the home page for business as well as services that we are looking for quick access. Also, there is a chatting feature wherein we can message and send requests to businesses or services. Smart ranking algorithm. This is a key contribution to our app. We use distance calculations, score combination, and weighted relevance. The distance decay function ensures closer providers receive higher priority. WD is equal to e to the power minus lambda into d, where lambda stands for decay constant and d is the distance with the provider. Then we find the final score, which is a combination of distance into proximity plus ratings into reliability plus personalization into personalized relevance. So the final formula is alpha into WD plus beta into R plus gamma into P. The challenges and limitations. First, vendor onboarding. Second, verification delays. Third, payment dependencies. Fourth, internet connectivities. These limitations highlight opportunities for further improvements to enhance overall platform performance and user experience. Platform positioning and comparative analysis. We have compared our platform skill base with other platforms such as urban companies and Just Dial.
I'm sorry to interrupt you. This is just a gentle reminder that 1 minute is left for your presentation.
Yes, ma'am. The experimental results and user feedback. Then we have the key features. These are our key features. And it also aligns with SDG 8 and 11. Our key features include backend integration and real-time sync, trust and verification, AI-powered personalization, integrated booking and payment solutions, advanced vendor analytics, data privacy and security, real-time chat and messaging, user engagement and retention, simplified vendor onboarding. Skill-based helps the small local workers become visible online, connect better with their community, and rely less on the middleman. Its flexible design allows it to grow in both cities and smaller towns, supporting local businesses and long-term economic growth. Thank you. We are open for any questions.
Session chairs, do you have any questions?
Can we means Skillbus is integrated with some government initiative, means like Digital India or any?
Yes, ma'am. Ma'am, can I get your question again?
Can Skillbus is integrated with government initiative, means like Digital
Yes, ma'am.
India?
It is.
Yes.
Yes, ma'am. It is integrated. Like we also have service providers who are just ITI pass outs from diploma colleges, so they are
Okay.
a part of our app.
Okay. Thank you.
Thank you, ma'am.
Thank you for your presentation, Sonia. Lastly, we have Domenico Vito presenting the paper titled Spatial Geoinformatics and Big Data Analytics on Marine Litter Monitoring. Domenico, your voice isn't clearly audible.
Give the floor to my colleague Caro Marione. Thank you very much for the opportunity, and please, Caro, you can go ahead.
Thank you, Domenico. And yeah, unfortunately, it's having some technical issues, so we'll take over the presentation. And we're presenting about spatial geoinformatics and big data analytics on marine litter monitoring. So just a quick word about like the context of our study. It's placed within the research for tracking plastic pollution, which is a constant presence in all aquatic system, especially looking at how rivers deliver 2.4 million tons like to the ocean every year. And also we place this research within the critical observation gaps, as currently there is like monitoring failure to track how debris move through the socio-technical pathways and how we can identify the economic causes for plastic pollution. In this study, we'd like to suggest like geoinformatics as a solution as we integrate satellite data and machine learning to offer a scalable way to detect, map, and attribute plastic sources, especially when looking at border regions. For this study, we also advocate an operational shift as remote sensing is moving from experimental to operational. We'd like to fill the gaps where the on-the-ground monitoring is not possible. For example, for some like area where there is limited availability. And finally, the study focused on transboundary issues, and in particular using open access imagery to track plastic along the US-Mexico international border. Concerning the methodology, we have a 3 steps methodology. The first step was like the satellite data collection. The primary data source was the use of multispectral imagery retrieved from the USGS Earth Explorer Landsat program. Concerning the sensor specifications for the research, we use like Landsat 8 and 9, featuring 11 spectral bands with 16-bit radiometric depth for high precision reflectance detection. Concerning the spatial and temporal resolution, we use a 30-meter multispectral resolution with a 16-day revisit cycle, which enable a consistent temporal analysis. For the data quality, we use level 1 orthorectified product and level 2 surface reflectance data. And finally, for positional accuracy, we use high geometric precision, less than 12 meters, ensuring reliable mapping across the study area. Concerning step 2, we have the image processing. For spectral contrast enhancement, we exploited the high reflectance of floating plastic in the near infrared and short wave infrared bands compared to the high absorption of water. For the reflectance-based detection, we leverage specific absorption peak to distinguish plastic from the surrounding water surface. For the index, we use the normalized difference vegetation index, which rely on near infrared and red bands to identify bright floating materials. And this was combined with the normalized difference water index, which is used to delineate water surfaces to maximize misclassification of pixels. Following, machine learning was integrated in the process, employing an artificial neural network algorithm to improve border recognition and identify specific plastic patches. And finally, we validated our framework, building upon established spectral signatures such as red edge effect to differentiate plastic from natural aquatic material. And here you can see an overview of like how this process was for the identification of plastic debris. Following, we use in situ observation to provide a ground truth validation of our data, and monthly in situ are conducted between the months March 2022 and April 2025 by a specialized team of like 4 researchers. We use the distance sampling method, which was applied to an established protocol to record the GPS coordinate, the plastic category of the identified debris, and the estimate waste coverage over like a specific perimeter. We also use multi-camera documentation using a high-resolution photographic array, mixing digital camera, GoPros, and mobile sensors for independent site capture and error reduction. For source classification, we categorized litter into land-based, which was originated from the packaging, construction, or household sectors, and into sea-based, mainly coming from fishing and tourism sources during the post-screening. And finally, we had an independent verification, which was provided through a triangulation observation between 3 experienced researchers to ensure data reliability and minimize classification error. So through this research, we identified 5 plastic pollution hotspots, and they were mainly located on the US side of the border. And this research confirmed that this site were trapped transparent plastic endangering like coastal ecosystems. This site 1 and 2 were canyon collectors called Smuggler Gulch and Goat Canyon, which act as open air dumps, and their sediment they are frequently overwhelmed by unregulated urban waste and storm events, especially during the rain season. We also noticed that the contaminated barriers within this canyon, and due to contamination, recovery was like impossible because of sewage contaminated plastic, and also the area was like following restriction for protected species and different administration rule in the area, so it was very difficult to access. For site number 3 and 4, we had the Tijuana River and South Beach located in Imperial Beach, and despite being municipal cleanups like across the 2 areas, the river mouth caused like constant recontaminations. And finally, the last area was the estuary corridor, which served as the final getaway to the Pacific and as a wildlife refuge for endangered species with no waste collection service. So it remains a high priority area for contamination risk. So you can see here a map of like the 5 sites located on the US side of the border. And you see here the Tijuana River that originated in Mexico and flows like across California and out into the Pacific. Here is an overview of the satellite analysis finding for the canyon collector, site 1 and 2. We were able to capture the progressive filling and overflow of waste retention devices and identify buried plastic through indirect spectral indicators and texture changes. For site 3, the Tijuana River Valley, we observed dynamic storm-driven transport, especially during the rain season. And the site acts as a transient receptor where plastic move rapidly downstream rather than accumulating permanently. The fourth site, South Beach, was identified like persistent debris near the estuary outlet, and spectral signature confirmed a mix of land and sea-based input that were redistributed by coastal tide. And finally, the last site, the estuary of the river, was confirmed as a primary retention zone, and satellite data showed the bidirectional pollution from both upstream river flows and incoming coastal water. We also noticed the ecological risk, eye reflectance patches at the river mouth, interior sediment highlight, especially at the last site, as critical and causing eye vulnerability of the corridor into the marine environment. Concerning the interpretation and contribution of our research, we produced some actionable policy data, including infrastructure mapping, which identifies specific gap in the waste collection, such as like the lack of specific services, especially like in site number 5, the high priority site. We also did hotspot prioritization, pinpointing areas that require immediate intervention to halt leakages. And finally, the accountability. So maps provide a spatial footprint to help stakeholders address specific pollution sources. And it also acts as a primary waste drivers through the analysis of identified plastic food packaging as the most abundant pollutant, with a significant contribution from also the construction sector and the household sector. Like a novelty element of this research is also like the methodology.
Sorry to interrupt you. This is just a gentle reminder that 1 minute is left for your presentation.
Thank you. For methodological innovation, we integrate remote sensing with field validation, which overcome like technical limitations. And finally, concerning future direction, we propose the use of hyperspectral imagery and drone-based survey to improve resolution, as well as for the qualitative load estimate. And finally, for the conclusion, this study produced a robust and replicable framework that was established through a scalable methodology. It overcome the data scarcity for the area and also is a good example for transboundary pollution across international borders. Also, the dual layer insight as satellite analysis revealed the critical hydrological and storm-driven transport pattern, where field survey provided necessary detail on the waste composition. The high adaptability, as the framework was designed for easy replication in other areas with similar characteristics. And finally, the actionable outcomes of this study, as this was like a pilot study, successfully mapped the journey of waste, and it can also like be replicated to areas that suffer from similar issues. Thank you so much for your attention, and we're open to any question you may have. And I'll also open the floor to my colleague, Domenico Vito. You may use the chat if you still experience the technical issues.
Just a comment, I was saying before, this was an example of the use of AI technology also to foster and localize one of the SDGs, that is the SDG 14, this is life below water. We as Metabolism of Cities Living Lab, we are working towards that, and my colleague Carol has presented an example of our work into the San Diego State University Metabolism of Cities Living Lab.
Okay, if there's no other question, we thank you again for your time, and you can reach out like to the email provided on the slide if you have any questions or curiosity about our study.
Thank you. Actually, you have excellent work. Oh, I don't have any question here. Thank you.
Thank you.
Thank you, Carol and Domenico, for your presentation. Next, we have Dr. Tripti continuing her presentation from earlier.
Yes, is there one, right?
Hello?
Yes.
Hello? Yes, ma'am, I'm there.
Yes. You may please start your presentation.
Yes. I'll continue from the results parts.
Yes.
Yes. Just give me a second to share the screen. Okay. Okay, you can continue. नाही फोन नाही घ्यायचा आता रिसिव्हच नाही करायचा आता नाही I hope my screen is visible.
Yes, it's visible.
Okay. Just confirming the mic.
Yes, you're audible. Can you please change
Yeah,
your
just
orientation to landscape?
Yeah, orientation. Sure. I hope the slides are clearly visible.
Yes, they are. Please
Okay. Yeah. So I was explaining the results of the personalization and fine-tuning part. So as we can see that the Google Voice personalization we found that the Google Voice personalization performs better than the baseline word error rate has been improved, and the synthetic voices that we have tested, like of the recordings, they are having relatively less word error rate, but the natural voices, we got a few more word error rate. So according to this personalization and fine-tuning part, no, we found that Google Voice is giving better personalization, as we can see in commercial practices also. As we can see in commercial practices also, the Google Assistant performs better when we allow the personalization mode, and the improvement, significant improvement has been seen in with the Google Voice. Then if for the system profiles, I'll quickly summarize the results. So clean audio performance was excellent for DeepGram, SpeechMatics, Assembly AI, Microsoft Azure. Then for forensic audio, only DeepGram was performing best. The SpeechMatics has increased word error rate. Assembly AI was also excellent, but the Microsoft Azure was very poor on forensic audio, and the customization capability was good for Google, and as we can see, it was excellent for Assembly AI and Microsoft Azure. So as we can see here, there is a possibility that this experimentation can be further carried out. So the limitations of here, that we have used the natural recordings of iPhone. We were not able to use any recording room to record the voices, but the noise was introduced with the drums and typical noisy environment, the clumsy environment which is going all around while traveling through the bus or traveling through some clouded area. So that way we were able to collect the noise. So these are the limitations. So custom vocabularies can be a solution in this part, and speaker personalization for can be done with the pre-training kind of thing. So the future directions are for we can find more options for the robustness engineering. So and the noise cancellation kind of things can be implemented at the front end part, so that in the noisy environment also the clean audio will be passed to these APIs. Then hybrid ASR LLM systems can be developed to integrate the large language models for semantic understanding and domain specific post processing pipelines. So this one is the future direction, so that the mathematical and Greek symbols, the problem we faced with, has to be accomplished after with the post processing only. If we speak in alpha is equal to beta upon gamma, then the current ASR systems are processing it as ALPHA, means they are not using Greek letter alpha, they are using ALPHA. So the customization and the domain specific support can only be applied by using post processing. So with this, I conclude that the our study has focused on the 4 parameters that I mentioned earlier, that the accuracy on clean audio, accuracy on forensic style audio, then native support and customization. So out of which DeepGram, Speechmatics and WebKit speech recognition were able to achieve 100% accuracy on clean and high quality audio. Forensic audio is a major failure point. So performance degrades very drastically under noise. Then no native support for math or Greek letters was found. And customization is very much essential for vocabularies, LLM integration, and personalization help in synthetic voice. Personalization helps better in synthetic voices. So thank you. I'm ready to face the questions. Hello?
Yes, Trupti, you're audible.
Yeah.
Session chairs, do you all have any questions?
What are the limitations of that explainable AI in that legal setting?
I beg your pardon, ma'am. Actually, the explainable AI part was not in my.
Not explainable means just AI in that means in your framework systems like this.
So, ma'am, the limitation is like when we use the large language models or the end-to-end support, no, we don't have the customization in between. If we consider the previous kind of libraries, no, which were working by taking the audio and decoding a single word from the audio to text. Now the end-to-end architectures which are used in the Whisper or the Hubert, they are not allowing this personalization in between the speech processing pipeline. So that is the limitation here.
Okay. Thank you.
Okay. Any other questions, ma'am?
I think that's all the questions. Thank you,
Okay.
Trupti.
Yeah. I would really appreciate you provided. Thanks a lot to the organizers that for being for allowing me to present in this conference. Thank you very much.
It's okay. We appreciate your presentation. And with
Yeah,
that,
thank
we
you.
have concluded all the sessions for today. I would like to sincerely thank all the authors for the excellent presentations and valuable contributions, and also to the participants for staying with us till the closing remarks. On behalf of the organizing team, thank you for your continued support for ICTIS over the years. We look forward to welcoming you again at the 12th edition in 2027. All presenters will receive their digital certificates via email within 2 working days. The publication process will be completed within 7 to 8 months, so kindly extend your cooperation to the ICTIS 2026 team during this process. I would also like to thank our session chairs, Dr. Nyanti Kao, for effectively sharing this session. Ma'am, would you please like to share any closing remarks with us?
Thank you. Actually, once again, I would like to thank the authors and express our appreciation for your value sharing. Thank you for your attention and questions of the participants. I would like to thank our co-chair, Dr. Adi Rasan Suyavansi. Sorry, maybe I cannot pronounce your name correctly. Sorry about that.
No, it's correct.
Thank you, our moderator, Miss Sankiti. camera. I wish you all the best and hope to see you at the next year conference ICTIS 2027. Thank you.
Thank you for your kind words, ma'am. I'd also like to thank our co-session chair, Dr. Aarti Suryavanshi, for effectively chairing this session. And as a token of our appreciation, we present this certificate to you. Ma'am, would you please like to share a few words with us for the closing remarks?
Yes, sure. Firstly, I'm very thank you for the inviting me as a session chair, and it was a very fantastic and great and high energy session. And it also, and I was a part to be of this conference teams for VR Foundation Thailand. So, and thank you to all, and so Nathi Kao ma'am also. And, thank you so much.
Thank you, chairs. I would like to request everyone to please turn on your cameras so that we can have a quick snapshot of the session. Thank you everyone for joining us today. I hope you all have a great day.